Welcome back to Trig 6.4 Notes. This is part 2. We were talking about graphing hyperbolas. One of the things we talked about with a hyperbola is that it has either an x squared and a y squared term being subtracted from each other. So I noticed that there's a minus here. And the equation is always equal to 1. So the first thing I'm going to do is get this equation equal to 1 by dividing by 16. So I'm going to end up with y squared over 4 minus x squared over 16 equals 1. Now that I have it in the right form, I know that if the a is always the first term, so a squared is 4, then the b squared is the 16. If the a is underneath the y, that this hyperbola is going to be opening up and down because my transverse axis is vertical. So it's going to be an up and a down hyperbola again because the transverse axis is underneath is on the y side of the equation here. So what I know right away is that my center is going to be 0, 0. If my a value is, if a squared is 4, then a has to be 2. If b squared is 16, then b has to be 4. I can plot those points now, plot 0, 0, and then since a is underneath the y value, it's going to be going up and down, and b is going to be going left and right. So I'd go up to, for a vertex, I'd go down to, for a vertex, so that would be the coordinate points 0, 2, and 0, negative 2. I'm going to go right 4, and I'm going to go left 4. That's going to give me the box that I can draw now that will help me define where my asymptotes are. So remember, my asymptotes are going to be the dashed lines that go through the center as well as through the corners of that box. I'm going to recommend that you get a ruler out when you make those. So I can actually draw my branches before I even finish the rest of this. I know since it's going up and down that it has to go through the vertices, so one would be here, the other branch would be here. Let's go ahead and finish off what we know. We can find the c value by taking the fact that c squared is equal to a squared plus b squared. If you're trying to figure out how, I can't remember this and I don't want to look at the formula sheet. If your equation has a minus up here, then the relationship between a c is going to have a plus. And it's just the opposite for the ellipse. The ellipse has the plus here, so the relationship would have a minus here. So those are going to be opposites. So plugging in, let's see, 4 is a squared, 16 is b squared. I'm going to get c squared to be 20, and I'm going to get then c to be 2 square roots of 5. Now if I have to plot that, I need to figure out what 2 square roots of 5 is as a decimal, so I know how far to go over, or in this case up and down. I know that c is about 4.5 then. So from the vertex, from the center, I want to go down 4.5. 1, 2, 3, 4, 5, so it'd be right around here would be a focus point. And from the center, 1, 2, 3, 4, 5, so 4.5 would be right about there. That would be a focus. Just to confirm that I've graphed this correctly, does my graph, each branch, wrap around the focus points? Yes, so that's a good thing. Next thing I need to do then is write up those coordinate points. So notice that I went from 0, I went up 2 square roots of 5, so that would be 0, comma, 2 square roots of 5. And I went down, so it'd be 0, comma, negative 2 square roots of 5. When you're doing your focus points, your vertices, any points that you're trying to label, please make sure you give exact values, not the decimal. Don't say it is 0, about 4.5, and 0, negative 4.5. So make sure you're giving exact values there. And then finally, we need to write the equation for the asymptotes. Here is the generic form of it. It's got the a over the b. times the x minus h. That should make sense, because if I'm trying to find the slope of this line, because that's essentially what it is, we do rise, which is our a distance, that was a, and our run, which was our b distance, this was our b distance. So that's really how I'm getting that up a over b for this this type. So our k was 0, our a value is 2, our b value is 4, and our h value is 0. So if I simplify this, y equals plus or minus 1/2 x would be the equation for those two asymptotes. Okay, our next example says write the equation for the hyperbola with a center at the origin. So let's plot that. Center at the origin. That would be 0, 0. Vertices at 0 plus or minus 3. So we go up 3 to get a vertice. We go down 3 to get a vertice. So 0 plus or minus 3 were my vertices. And asymptotes at y equals plus or minus 3x. Okay, so how I would deal with this is if it's the vertices are going up and down, that means that my transverse axis is vertical. When my transverse axis is vertical, there's a couple equations that I know. My parabola is going to be in this form, where the a is underneath the y value. I also know that my asymptotes will be equal to this form. Y equals k plus or minus a over b times x minus h. Well, if I have that equation already, if I know that my equation is plus or minus 3x, what I'm really given here is, okay, I have no k value, I have no h value, I already know that from 0, 0. I'm given that 3 over b is, or excuse me, that a over b is equal to 3. So if a over b is equal to 3, make that a fraction, and you would find then that b would be equal to 1. So my b value would be 1 here for this problem, which means then that I would be moving over 1 from here to get the box for this hyperbola. Okay, so again the question is saying to write the equation. So do I have enough information to write the equation? Yeah, I know what k is and h is 0, 0. I know that a is 3 from here, so a is 3, and b is 1. So if I plug that in, I'm going to end up with y minus 0, which is just y squared, over 9, minus x minus 0, which is just x squared, over 1 squared, which is just 1, equals 1. Let me just finish in the rest of the information that we were given here. We already know the equations for the asymptotes. C and foci, I can find those next by using the relationship that c squared is equal to a squared plus b squared. So 9 plus 1 would mean that c squared is 10. So c is the square root of 10, which as a decimal is about 3.2. So to plot those, I would go up 3.2, 1, 2, 3.2, that would be a focus point. I would go down 3.2, so right around there would be my focus point. So in terms of a coordinate point, I went up 3.2, or I went up the square root of 10, so it would be 0, comma, square root of 10. And 0, comma, negative square root of 10. Again, notice I'm giving an exact value here. I'm not adding the approximately 3.2 to that. So really what the question was asking for was this. But I wanted to go through and find all of the information that was listed out here as well. Write the equation for the hyperbola with the center at 0, 0. So that means our hk is 0, 0. Vertices at plus or minus 2, 0. So go over this way for a vertice, go over this way for a vertice. That means that our a value has to be 2 then, that's going to be important, and passes through the point 3 comma square root of 3, that means that is an xy value in my equation. Okay? So what I know now is since the vertices are going horizontal, the transverse axis is horizontal. Which means that the generic form of the equation would be the x minus h squared portion first over the a squared. So let's think about what do I know. I know hk, 0, 0. I know that a is 2, so that'd be 2 squared. And I know an xy value. X is 3. Y is the square root of 3. Now the thing that I need to know to be able to write the equation, I need to know this, I need to know this, and I need to know what b equals. Once I know those 3 things I circled, then I can write my equation. So I can plug all of this information in and solve this equation for b, and then go back and plug it in to write my final equation. So it'd be 3 minus 0 squared over 2 squared equals square root of 3 minus 0, not equals, sorry, it should be minus. Square root of 3 minus 0 squared over b squared equals 1. So cleaning this up a little bit, 3 minus 0 is 3, 3 squared is 9, 2 squared is 4. Square root of 3 squared would be 3. So now solving this, I'd move over the 9/4 by subtracting. I'm going to get the negative 3 over b squared equals negative 5/4. A couple ways I can solve this. I know that it's 2 fractions that are equal to each other, so I can cross multiply. Or I can multiply both sides by b and move things over. I'm going to choose the cross multiply method. So negative 12 equals negative 5b squared. Getting rid of the negative 5, I'd get 12/5 equals b squared. So for me, I'm going to leave it at b squared because that's really what I need to know for my equation. So I'm going to change this to b squared being equal to 12/5. So now I can plug into there 12/5, and I don't need the x and the y value anymore when I write my generic form of the equation. So it looked like this, x squared, because of the x minus 0, over 4 minus y squared over 12 over 5 equals 1. Now the last thing that I want to do is we don't normally see a fraction down here, so to get rid of the fraction, let's just multiply by the reciprocal. Move it out of here by putting it up like that, and we would end up with our final answer then as y squared over 4 minus, this would make 5y squared over 12 equal to 1. So when you have a or a b squared value that is a fraction, plug it into where it belongs, get it out of the bottom by multiplying by the reciprocal, and now you can see that I don't have a fraction anymore inside of a fraction.